Hello. So we are back Friday, and we have to fix a laptop. This is a nice laptop. Yeah? It has a graphic chip, processor, dedicated graphic chip. Okay, M2 hard drive. Battery is pretty dodgy. Has no screw, nothing. Okay, it's a Acer full HD screen. Okay, the problem with this one, we have the orange light. Yeah, the charging light. Unplug, plug back. Pressing the power button is on the keyboard, and nothing happened. Okay, so the laptop is just dead. That's how we booked in the job. Okay, it's a dead laptop. Nearly dead. You still have this light, but that's all what we have. So basically, this is a torch. Good. What do we check? Yeah, because this is the worst case when actually looks like it's fine, but it's not coming on. Like what that orange light means our main power rail is fine. Our 3.3 volts power rail is fine. Okay, so why is not starting? That's a good question. Well, let's check. Yeah. So first, 19 volts, so you can check on any power supply. You see those coils, and you see those chips. Actually, these are the drivers of the coils, because this is a new model. Everything is inside, like the motors are inside of this chip. So we can check our main power rail here. So look on the screen, 19 volts. Yeah? You can see on the screen 19. Good. The 3.3. How do we check the 3.3? This is a new laptop. On the new laptops, the BIOS chip is just an image, or let's say this is the BIOS chip and you have an image here, and this chip, the startup chip, the Super IO chip, it's working with the inside image. Okay, when you reset the laptop, then it will start reading from this chip. So on the pin number 8 we have no voltage, so the 3.3 you can only check here on the Super IO. Just look for the big trucks or big resistors, like here you see this big resistor, you can't see it. Let's go under the microscope, because obviously we don't have schematics, so we are not sure where the things are. But when you check 3.3 on the Super IO, you look for big trucks, big things. Yeah, like this. Look, you have a big resistor, then a diode. Here another big resistor. So let's check here. Here we have nothing. And on this resistor, check on the screen, we have 3.3 volts. 3.291. Nearly 3 volts. It's fine. So the Super IO has voltage. Now the question is, everything is fine, then why the Super IO, when I press the power button, is not starting the board? That's the question. And the answer is, either the Super IO doesn't know you press the button, or the Super IO is dead. Okay, it's not reading the power button because it has a malfunction. We can check if the power button is working, and the easy way to check that is stick the ground somewhere, and you have the keyboard connector here. Okay, one pin you should have 3.3, and when you push the power button, because the power button it is on keyboard, is going to 0. That means the power button it is working. Okay, already I check and I know which is the track. Okay, so the track of the power button is this, is the second one, and we have 3.2. Now let's press the power button. I will press it for you, and it's going down to 2.7. You can see on the screen. Now releasing the power button, 3.2. Pressing the power button, 2.7. It's not meant to work like that. Yeah, 2.7 or 3.2 is still logic level 1. Yeah, so if I remember, to be 0 you should have like 1.82 volts, like minimal, to change the state from 1 to 0. So we know for sure we have a we have a power button issue. Yeah, so the power button, it's acting like has a resistor in a serial mode. So instead of dropping the voltage down to 0, it's dropping the voltage down to 2.7. Okay? How we can test? Maybe you have more issues if the laptop is working. Very easy. We short that pin to ground. Yeah. So I'll take my tweezer and I will short that pin to ground. Check here. We have the blue light, and we have the picture, and it's loading the Windows. So what do you think about this? Most likely, what happened? Probably the customer dropped some liquid on the power button, because you know what? I did load the Windows and I checked the keys, and the keys are working. The only key what is not working is the power button, this one. So the problem with this laptop, it is the keyboard. Okay, so what we can do, what you will do in this case. The job is well paid. Obviously, this came here like a dead laptop. What you'll do, you can't fix the keyboard. The keyboard, it's you can't open the keyboard and fix the keyboard. And also over the keyboard, you have this metal with this, you know, it's welded with these plastic bits. Yeah, it's not that easy to be replaced, but it can be replaced. Now, probably 99% from the people watching this video, you'll say, sorry, it's nothing to do. Just order a new keyboard and replace the keyboard, right? Actually, you are right. I can't fix the keyboard. Yeah. But you know what? If you go back in time like 30 years ago, and you are working in a shop and you tell someone you have to replace the whole thing because one button is not working, you will get fired. You know, it's we are in an age when we are just replacing. No one is fixing anymore. It's just one issue with replacing the keyboard. Replacing the keyboard means I will earn less, and that's not good. I want all the money, you know. I don't want to share. How much can be the keyboard? 25, 30 pounds, maybe 40. I don't want to share that money. Sorry. So we'll fix. Let's say we will use what we have. Yeah. So we have a drop from 3.3 to 2.7 to 0.6 volts. Yeah. So we will use this in our advantage. We'll modify the manufacturer schematic, and we will make this working. Okay, and we will get all the money. Okay, from this job. We are not sharing anything. First, yeah, you have to figure it out the schematic. Okay, let me open the things. And on the end of the day, I don't even care about money. It's all about the time, because you have to put back the laptop, order the keyboard, wait for the keyboard, open again the laptop, take this bit out, replace for what? The keys are working, only the power button is not working. Actually, the power button, it is working, but it's acting like has a resistance in a serial mode. Yeah, that's why it's not dropping the voltage to 0. Okay, so we do have access now here. All we have to do is to understand the schematic. Okay, and let's try to understand. If you understand the schematic, you can modify it. Let's see, what do we have here? We have that pin. Let me switch to diode mode. Yeah. So this is the power button pin is coming here. Yes, 0. Is going for a resistor and a capacitor. Most likely this is the ground here. Yeah, it is ground. So I have here a resistor. Then the truck is going somewhere. Okay, you can see. I don't know where, but we have to find out. And for that I need my beeping multimeter, which I'm really sorry, but it's not on the screen, yeah? So we have to find the truck, because the truck clearly is going somewhere near to the Super IO. Okay? So I haven't checked, I'm not sure. I have the beeping multimeter here, so it should beep. Here. Oh, you can see here, this is beeping here. So the truck is coming here, yeah? The question is... Oh yeah, it's clearly, yeah, you can see, now look here. This is going to the power button, okay? And also is going to the Super IO pin. You can see this pin. And also here I can bet this is plus, yes? I will check this with plus, we hear. It is plus, it's beeping, you can hear beep, beep, yeah? So let's clear this and let's draw the schematic, yeah? Let's do it. So what do we have here? Because if you understand, it's easy to play. So what do we have? We have the Super IO, yeah? Super IO chip. And then you have a resistor, yeah? That resistor which on the other side is plus, yeah? So this is going to plus 3.3 volts. Then from here, yeah, what we check? We have a capacitor to ground, okay? Then we have a resistor. Then we have the keyboard connector. So from here we have the power button. That's the schematic, yeah? Now this line it's keeping to plus. It's keeping to plus. It's, you understand, if you don't push the power button, you'll have 3.3 coming from this resistor. When you push the button, you switch this voltage near to 0. Yeah? Here near to 0. Here must be 0. Okay, but you have a resistor, still you have a resistor here. So our issue is, right now, we have a second resistor in the serial mode with this power button. That's how it's acting. It's acting like we have another resistor. Okay? So what we can try first? First, we can try removing this resistor, and maybe it will work. If it will not work, we will change the value of this resistor, because right now when you push the power button you have a divider, yeah, you have one resistor here and one resistor here. It's a voltage divider. So if it's not working, just shorten this resistor, we replace this resistor with a higher value. Okay, simple. So first let's try and short that resistor. What is it? What is it? What is it? Here. I'm not sure what's the value of this resistor. Let's check together. Let's see, ohms. It's not important, it's just for my knowledge. $33 ohms, really? Okay, I don't think anything it will change if we'll short this. So probably nothing will change. But let's do it. Let's do it. Let me grab a wire. We need a tiny wire. We need some flux. So we have this from here, a bridge to here, yeah? Right? Okay. Let me cut this wire. All good. Let's check now. Let's check together. Plugging back the keyboard. Plug in the charger. Let's get the multimeter, volts. Volts. Then we have here, what voltage do we have? 3.3, pressing the power button. And it's going to 2.6, 2.5, but the laptop is still not coming on. Let me plug the battery back. Okay, we have the orange light. You can see it there. Now the problem is if I press the power button, let's try one more time. .2, pressing the power button, like 2.7, like nothing changed. Pressing the power button, 2.7, nothing changed. Okay? Because the resistance was very low ohms. So what we will do in this case? In this case, like how I said on the beginning, we have to modify the other resistor. Okay? This one, yeah? This one. What value has this one? Let's see. If we can get a right value of this. This one has 10 kilo ohms, 9.7. Yeah, that's the value of this resistance, 10 kilo ohms. So I think we can, if we can replace this resistor with like 47 kilo ohms, I think you know, it will work. Let me try to find the small nozzle so we can remove that resistor. Okay, let's use a little bit of flux. Good. Let's remove the resistor. Okay, the resistor is removed. Now let's find another one. Where we can find another one? Microscope. Let's get another board. Let's try and find a resistor. We have the meter on screen. The problem is I can't see anything. Let's check together. Let's see, what do we have here? 24 kilo ohms. Okay, not bad, but we need something better. This is 42 ohms. This one is 1 kilo ohm. A 100 kilo ohms. We should try with 100 kilo ohms. It's a little bit too big. 30 kilo ohms. What do you think about this? So which one it is? It's 20? We don't know. Because it's tricky to check the value of the resistors on a board, you know. You have to desolder and check. Okay, but I will check. No, I'll leave it here and I'll check. What's the value? 46 kilo ohms. Perfect. Yeah. So let's get this one. Okay, and move it. Okay, I think it's no point. My resistor just fly somewhere. That's crazy. It's gone. Well, then let's go with 100 kilo ohms, but I still believe that's too big. It's still too big. But we can try, you know. This one, if I remember, yeah. Okay, let's solder this. You know, I'm scared if I will lose this. You know, that's not good. Yeah, some flux. And now let's solder this thingy. You know, those components are so small. So small. Okay, now it's not anymore. Even this one goes somewhere. This is crazy. This is insane. The second resistor, I lost it. You can believe it. Let's find another resistor. Yeah, the 100 kilo was not a good value anyway. Let's try and find another one. This one, 10 kilo ohms. This one, 80 kilo ohms. Okay, this one, 90. Nothing. Ten kilo ohms. Okay, I think I'll go with this one. 80 kilo ohms. Let's see. Which one was this or this? Huh? Any? Okay. The resistor it is on place. Let's see. Okay, we can plug the charger and let's see what happens. Plug in the charger. We still have the orange light there. Let's check the voltage. Volts. Ground. And the pin. And we have 3.2 volts. Now let's push the power button. And it's going to 2 volts. And it's still not working. I think it should be under 2 volts to work. But let's see what value is this. Let me unplug the charger. Ohms. A 100 kilo, I can't believe. So with 100 kilo, we are going down to nearly 2 volts. Well, I believe it's time for another resistor. Actually, I can check exactly if we're using some math to check what resistance has the power button, what resistance we need. We need a bigger value, 75, 100 kilo. Maybe we can find straight away like 200, 300 kilo. 40 kilo. Nothing. Actually, the hard part here is to find another resistor. .2. How hard is to find a resistor these days? Really hard. You know what? I'll go back. I'll get 100 kilo ohms on. If I remember, let's see. If I remember, one from here was 100 kilo, yeah? And I'll stick it on serial mode. $40 kilo. 100 kilo ohms, yeah? This one. I guess I'll get that one. I'll solder on a serial mode. Here. Okay? Ah, come on, come on, come on. Hey, I think I found it. 1 second, I found it. I found it. But the question is our resistor or this one we lose it last time? Let's see. 100 kilo, yeah, that's ours. Good. Come on. Okay, let's try and do a trick. If we can do a trick. Good. It's solder. Oh, you can't see, sorry. So looks good. Perfect. Let's check now. Volts. And we have the power button. 3.2, pressing the power button is going to 1.8 and it's still not starting. Come on, this. So it's going to 1.8 volts, but I still don't have the blue light. Okay, let's check those resistors around the LAN card, yeah, the big coil. You see here should be like high ohms resistor, mega ohms. You know, I'll stick a mega ohm resistor. And do we have any resistors? No, we don't. You know, just fast forward the video if you get bored. What we can do? These are ohms. This is 200 kilo ohms, but we need bigger, yeah? 500, 600. 100 kilo ohms. There's a capacitor there somewhere. Probably I will not find any mega ohm resistor here. No, we're not gonna find. Where can I find mega ohms resistors? You know what? You should have a stock with every resistor, like SMD resistors. Right? 100 kilo. But that's not enough. I don't think I'll find one. I think we are just wasting time. I should buy all values, of the resistors. I should buy resistors a lot and have them here. 200 kilo ohms. Another 200 kilo ohms. We can use two, but that's still not enough, right? How about 1 mega ohm? You know what? I will get those resistors, 200 kilo ohms each. Yeah, let's see if it's working. I'll leave them on one side. Okay. I'll remove those. Okay. Good. Yeah, I need some flux. Let's check the value. Multimeter. 370 kiloohms. Let's see now. Pushing the power button, hopefully it's working. I don't even check the voltage. Pushing the power button and it's not working. Let's see why. Sorry, voltage. .2, pressing the power button 1.8. Okay, let's do something else. Let's add a resistor in the here. Let me unplug the keyboard. Let's add the other resistor to ground. We'll remove that capacitor. So we remove this one. Let me find a resistor here on my table. We can find any. Yeah, I found a resistor. Let me see what value it has. 1 second. Where is it here? Ohms. Oh no, this has 10 kiloohms. Okay, you know what? You know what? Let's remove one resistor from here. Okay, let's move a resistor here. Come on. Good. Let's solder this one back. So, yeah, we will not have 3.3 there. We'll have like half because the resistors are the same. we have the orange light, yes. Pushing the power button. Come on, man, come on. Let's see. Volts. 2.9, pushing the power button, 1.6. With 1.6 is not starting. This is crazy. So I have 3 volts, yeah, pressing the power button 1.6. So what level 0 means for this chip? So what is level 0 then? Level 0 is 0. Right? Let's find. Now let's find 100 kilo ohms. Or 50, you know. Wow, it's nearly 1 hour. I can't believe. I was expecting this job to be quicker. I see this one. 14. 100 kilo ohms. Well, let's get the 100 kilo ohms one. And I will put it on parallel mode with the other one. Yeah, which one? This one? Yeah, that one. Adjustable resistor will be nice. Perfect. Let's see now. Now I'll press 3 the power button. And now it's not working. Let's see why. We have 0.8 volts. Pressing the power button, it is going to 0. But the voltage is too low. Why only want 0.8 volts? Hmm? We have 50 kilo ohms. Okay. Let's give me 1 second. Okay. So we remove that resistor. Pressing the power button is not working. That's great. Oh yeah, it is working. It's on. You can see the blue light. But there's no picture because we took out some things like RAM memory and... Let me check the voltage, yeah? So we have voltage. We have 2.6, yeah? Pressing the power button, we have 1.5. I think it's starting with 1.5. Let's try one more time, plugging back the charger. Pushing the power button. Pushing the power button, it is coming on. That's fantastic. Let's put back the RAM memory. Let's see. Power button is working every time, no bootable device. Let's take the hard drive. Yeah, it's awkward job. But what we can do? You know, we spent 1 hour, but at least we fix it. So one more time, we have the pressing the power button, and we have the blue light, and it's coming, going, and it's working fine. So what we did, because I didn't have here a high value, you remember? I come with a resistor on a parallel mode. Yeah, remember we short this one, and I came here with a resistor to ground, and I pulled the voltage down. Oh, this was a long video. One more time. Pressing the power button, and we have the blue light, and it's coming on, and it's working. Okay. If we keep press the power button, it will shut down. No, it's not doing it. No. Pressing the power button. If I press short, it's not going off. That's sick. You know, I'll let the customer shut it down from the windows. It's crazy because the power button, it is working. So we plug the charger, yeah, it's off. Pressing the power button, it is coming on. It's working, so from my point of view, the job is done. A little bit dodgy, but you know, we made some money. Customers save some money because we don't have to order the keyboard. The job is done, you know. It's just funny because you know, I can see the comments. You know, another dodgy job. It means the point. We have a working laptop. Yeah. Okay. So I'll stop now. Have a great and fantastic weekend, and see you next week. Probably Monday. Yeah. Bye.